Welcome back to Linux Essentials, Episode 2. If you've ever typed LSL and stared at something like -rwxr-xr-x, wondering what on earth you're looking at, this one's for you. Today we're decoding file permissions. Read, write, execute. 3 simple actions, 3 groups of people, and a system that's far more logical than it looks. So here's the wall almost everyone hits. You try to edit a file or run a script, and Linux flatly refuses with permission denied. You glance at level, see something like -rwxr-xr-x, and maybe a mysterious number like 755 floating around in tutorials. And it all reads like line noise. The good news? It's actually a tiny logical system, 3 actions, 3 groups of people. Once you see the pattern, you'll read any permission string at a glance. So let's nail down the definition in one breath. File permissions decide who's allowed to read a file, write to it, or run it. And Linux splits that question across 3 audiences: the file's owner, the group it belongs to, and everyone else on the system. That's the whole framework. 3 actions, 3 groups, and 2 commands, chmod and chown, to change them. Everything else we'll cover is just notation built on top of that idea. Let's zoom in on those 3 actions. Read means exactly what it sounds like. You can open the file and view its contents, or if it's a folder, see what's inside. Write lets you change the file or add and remove things in a folder. And execute is the interesting one. On a file, it means you can run it as a program, and on a folder, it means you're allowed to step into it with CD. Same 3 letters, slightly different flavor, depending on what they're attached to. Now, those 3 actions don't just exist in a vacuum. They apply to 3 different audiences. There's the user, that's you if you created the file, the owner. Then there's the group, a set of users who share access. Think of a team working on the same project. And finally, others, which is basically everyone else with an account on the system. Each of these 3 gets its own independent set of read, write, and execute. And honestly, that's the entire permission system right there. So let's put it all together and decode that scary-looking string from the start. Read it left to right. The very first character tells you the type, a dash for a regular file, a D for a directory. After that, you get 3 triplets of 3 characters each: owner, then group, then others. In our example, the owner has full RWX, read, write, execute, while group and others only get RX, meaning they can read and run it, but not modify it. Any dash you see just means that particular permission is switched off. That's it, no more line noise. Now, you've probably also seen permissions written as numbers, like 755 or 644, and there's a neat trick behind that. Each letter in the triplet has a value. Read is 4, write is 2, execute is 1, add up whichever ones are switched on, and you get a single digit per group. So RWX, all on, becomes 7. RX, just read and execute, is 4 plus 1, which is 5. That's how 755 means RWX for the owner, and RX for everyone else, and 644 means the owner can edit, while the rest can only read. In practice, you'll see the same handful of numbers over and over. 644 is your everyday file. Owner writes, everyone reads. 755 is for scripts and folders, where others need to run or step inside. 600 locks things down to just you, which is perfect for SSH keys or private configs, and 777, that hands the keys to the entire system, almost always assigns something's gone wrong, not right. Memorize these 4, and you'll read most permissions at a glance. Now that you can read permissions, let's change them. And that's where chmod comes in. You've got 2 flavors: numeric, like chmod 755, which sets the whole permission string in one shot, or symbolic, which reads almost like English. Want to make a script executable? Chmod +X, give the owner write access, U plus W. Strip read from group and others. GoR, pick U, G, O, or I for who, then plus, minus, or equals for what. Add, remove, or set exactly. Chmod handles what people can do, but chown handles who they actually are. Every file has exactly one owning user and one owning group, and chown reassigns either or both. Sudo chown Anna gives the file to Anna, and Anna.divs sets the owner and group in one go. If you just want to swap the group, grp does that on its own. And yes, you'll usually need sudo, because handing a file to someone else is an admin-level move. And speaking of admin-level moves, there's one user who doesn't play by these rules at all. Root. Root is the administrator account, and every permission check we've talked about, the rwx, the owner, the group, root simply ignores. That's why sudo exists. It lets your normal user borrow root's powers for a single command and then hands them back. It's incredibly useful, but it's also the fastest way to break your system, so reach for it deliberately, not reflexively. Now, before we move on, let's clear out 3 myths that trip up almost everyone. First, chmod 777 does not fix permission errors. It just throws the doors wide open to every user on the system, which is a security hole, not a solution. Second, the execute bit isn't a virus risk on its own. It just means a file can be run as a program. Scripts need it. Your photos and text files don't. And third, owning a file doesn't automatically mean you can read it. If you strip the R bit from yourself, you locked yourself out. Root can still get in, but as a normal owner, you follow the same bits as everyone else. With those myths cleared, let's turn them into habits you can actually live by. The rule of thumb is least access needed, 644 for regular files, 755 for scripts and directories, and 600 for anything secret like SSH keys or config files with passwords. And before you ever reach for chmod, run lsl first, see what's actually there. On the other side, avoid chmod 7 nuts and 7 as a quick fix. Don't sudo out of habit, skip the execute bit on plain data, and never ever leave a private key world readable. Speaking of habits, let's lay out the toolkit you'll actually reach for. LSOL is your eyes. It shows you who owns what and what they can do. Chmod changes the permissions, chown changes the owner, and chgrp swaps the group. Then there's sudo for when you genuinely need root powers. And umask, which quietly decides the default permissions every new file is born with. 6 commands. That's the whole kit. So let's pull it all together. The whole system is 3 actions: read, write, execute, across 3 groups: user, group, and others. You read a string like rwxr-xr-x leaf to right in triplets, or you speak it in numbers, where R is 4, W is 2, X is 1, giving you the classics: 755, 644, 600. Chmod changes what can be done. Chown changes who owns it, and root or sudo overrides the lot, so wield that one deliberately. Here's the one mental model that makes all of this click. It's just a 3x3 grid. 3 actions: read, write, execute, across 3 groups: owner, group, and others. 9 little switches, 2 ways to write them. Once that grid is in your head, a string like -rwxr-xr-x stops being line noise and starts reading like a sentence. Owner gets everything. Group and others get read and run. Same information, just less intimidating. And here's why this tiny grid is worth mastering. Permissions show up everywhere in the Linux world. They're stamped on every file in the tree from episode 1. They're the other half of the story when we talk about users and sudo next. They're the starting line for hardening a system. And out in the DevOps world, misconfigured permissions are behind a surprising number of real breaches. Least privilege as a security principle? It begins right here with rwx on a single file. So if this episode lit a spark, here's where to take it next. The Linux Essentials track walks the same path we've been on: the file system, permissions, the command line, then users, groups, and sudo, and finally processes and packages. Each piece builds on the last, hands-on, until running a Linux box actually feels comfortable. Everything lives over at dargslan.com, taught courses whenever you're ready. Before we wrap, I've got one honest question for you. Have you ever chmod 777 something just to make the error go away? No judgment. Most of us have done it at least once. I'd love to know if it ever came back to haunt you, and whether those three little digits actually make sense now. Drop your story in the comments. And that's RWX, decoded. What looked like line noise at the start is now a tiny logical system you can read at a glance. 3 actions, 3 groups, no mystery. Next in the series, we're tackling the command line basics, the shell skills that tie all of this together. Hit subscribe so you don't miss it, and I'll see you in episode 3.